Welcome guys to what may be the last of our Gizmo video tutorials for this year. Now we will be using this Gizmo as our primary lesson for this week. So I'm not going to go into great depth except to just kind of show you the way this Gizmo works so that you'll be able to understand what we are doing as we get into our class this week. What we are doing when we are identifying any given mineral is we are looking at the sample for different characteristics, just like we are with the characteristics of an animal, but these are the characteristics of some particular kind of rock or mineral. The 5 things that we are going to be documenting are the appearance, the density, the hardness, the streak, and acid reaction. Now, there are other characteristics that you can use on different rocks and minerals, but these are the ones that are being tested here in this Gizmo. And we'll test every one of these 5 for every one of these samples. Now, we can go to samples. There are many samples in here that you're going to be able to try out. But I'm just going to go through a couple to show you the way this is going to work. We're going to start off with sample A. Now, the first thing we're going to do is we're going to look at the different appearance of it, right? So what does this look like? That's the appearance of it. Well, first of all, this looks more like a hexagon, I'm going to say, if I were going to guess. So I'm going to just jot down on a piece of paper that this has a hexagon shape. When I look at the luster examples, that is how much, how shiny is it? Is it shiny? Is it dull? Is it pearly? Is it glassy? Or is it metallic? Now, I would say that this one up here looks somewhere between glassy and pearly, right? Probably glassy would be closer. But these are the shapes and the colors that we're going to see. It's kind of glassy, pearly, and kind of a whitish color. Let's take a look at its density. Now, this is the one where we're going to have to do some math, guys, so bear with me on this. We talked about this early on in the year, and that's one of the reasons I really like this Gizmo is because it practices this skill of calculating density. What we're going to do is we're going to take this, because it is an odd shape, we can't calculate its volume, in other words, how much space it occupies. We can't do it easily by measuring it. So the other way to calculate the volume of something is to dunk it into water and see how much it is displacing. In other words, how much does the level of the water go up when we put this rock, this mineral down in it. Started off at 40, okay? And when I put this in here, we now have, let's see here about, let's see, there's 42, 44, 46, 48, 50, 52, 54 milliliters. So that means we are going 14 milliliters up. 14 milliliters of space, 14 milliliters of volume. That is the same thing as a cubic centimeter, a cubic millimeter, excuse me, a cubic millimeter. Now, if I put this down here to see what its mass is, it's 36.4 grams. Now, to calculate its density, bear with me here, to calculate its density, what I'm going to do is I'm going to divide the mass of 36.4 divided by that 14 cubic millimeters, which is the same thing as a milliliter, and that comes out to 2.6 grams for every milliliter. 2.6 grams for every milliliter. Now, when I look at my chart that I'm going to be comparing this to, You can see over here under the density, right, the different grams per milliliter. So already I'm going to be able to narrow this down to something that is 2.6 grams per milliliter. Now there are only 3 of those that are here in my chart, and that is quartz, kaolinite, and feldspar. And then we look at the crystal or the shape. This one says rectangle or irregular. I don't think that one really was what we were looking at. Irregular or hexagon irregular. So I'm beginning to think that we may be looking at some quartz. But we're going to have to look at it. We're going to look at the hardness, the streak, and does it fizz when acid is dropped onto it. So let me go back to my gizmo and let's continue looking at this sample. Okay, so we now know that it's 2.6 grams per milliliter, and we know that its appearance was hexagon and a bit irregular. Let's check its hardness. Now, hardness is kind of cool here, guys, because what you're going to do is you're going to bring it over here and scratch it against these different objects. So against glass, it is harder than glass. So it's more than 5.5. Let's see, it even scratches a steel plate. So it is more than 6.5. That means it will definitely scratch a penny, and it will definitely scratch a fingernail. Okay, so we are looking for something with a hardness above 6.5. I think we're going to find this to be our quartz. Our streak. Now, when we do our streak, that's just simply to scratch it across this streak plate and see what the color is. There is no streak. It produces no streak when I scratch it across the streak plate. Okay, so jot that down, no streak. And the last thing is, does it have a reaction from acid? Let's drop a little acid on there. There is no reaction, no fizzing when I drop acid on there. So now I'm able to go back to my chart to be able to identify this. I said I thought it was going to be quartz because it was a hexagon, irregular shape. It was variable in color and kind of glassy. 2.6 grams per milliliter of density. Remember, that was by the space that it occupied that we displaced in the water. The hardness of 7, because we said it was harder than even the steel plate. No streak when we pulled it across there, and it does not fizz when we drop acid on it. So let's see if what we truly have is quartz. I'm going to type that in up here, quartz, and let's submit to see if we got it right. That is exactly what it is. Very good. So we guessed this first sample as quartz. We can try another one doing the same kind of thing. Let me see where we are up here. Why this won't drag. But we can start off with some acid. Okay, no reaction on the acid. Let's see about our streak. Okay, it leaves a white streak. So if we can remember these. Its hardness. It's harder than the glass. It's not as hard as the steel plate. So it's got to be more than 5.5 and less than 6.5. Will scratch the penny and it will scratch the fingernail. Let's check what else we have. Its density. Once again, this is an irregular shape. There's no way to check its volume except to drop it in this graduated cylinder, which starts at 40 and it goes up to 62, 64, 66, 68, 70. So that means it is going 30 milliliters. It's got 30 milliliters of volume over 78 grams. So we simply divide 78 grams divided by 30 milliliters of volume. And that's going to give us 2.6. Once again, 2.6 grams per milliliter. So remember that, 2.6 grams per milliliter. What is its appearance? Well, I would say it's kind of pearly and it is irregular. Okay? It's pearly and irregular. Let's check our chart one more time. And let's look at our possible selections, our possible minerals for 2.6 grams per milliliter. That's a good way for us to be able to narrow it down. Could be feldspar. It's got a white streak. It did not fizz in acid. A hardness of 6 because we said it was harder than glass, but not as hard as the steel. When we check that out, it's a pink or a white or a pearly, and it is rectangle or irregular in shape. Let me see if there's anything else it might be. Let's see here. Nothing else that is 2.6. So let's see if what we have is feldspar. Feldspar. Let's check it out. That's correct. So you can see, guys, that what this is going to allow you to do is to check a lot of different samples to see which one matches up on all of these different tests: density, hardness, streak, and acid reaction. Once again, we will do this in class, guys, so don't feel like you're overwhelmed, but you can get in here and play with it a little bit prior to class, just so that you'll be familiar once we get in here and do it together. Go ahead, you will have the student exploration sheet, so you can play around with it some, and then we will have some fun with it in class. See you then.